So now we're doing polynomial inequalities, and there's basically just two steps that you have to use. The first thing you're going to do is try and find the zeros. So we already know that our polynomials, don't draw this, but are going to do this kind of motion, nice and smooth and continuous kind of stuff. And so it's going to cross the x-axis at our zeros. And then part of the graph will be greater than 0. So this is our y equals 0. These are our zeros. And then part of the graph will be less than 0, like here. And so what you're doing is you're just going to be finding these zeros and then locating the regions that are less. So you can see here it's greater, and then here it's less, and here it's less. And we're going to write the areas that it is greater than or less. So it's those steps. It's really only two. So first thing you're going to do is find the zeros. So we take our x squared plus 6x plus 8, and we set it equal to 0. And this one will factor, so we get x plus 4, x plus 2. So we get x equals negative 4 from x equals negative 2. And then you draw a line, and you put a dot here at negative 4, and you put a dot here at negative 2. And then you go back and you look at our parent function. So we do have x squared here. We already know that's a parabola, so we don't need a calculator to figure out the shape. We don't need to look at end behavior. We already know what it looks like. So our parabola will look like that. That's the end behavior, and it does this. We already knew the shape. So now you go back to the inequality, and this one says that we are looking for less than. This is less than. So we go over to our graph. This is where our function will equal 0. These are our zeros. And you shade the part that's less. So right here, this is our less than of our function. And then you write the interval that includes it. So since it has a less than or equal to 0, that's this, we use a bracket because it's equal. And you write negative 4, negative 2. Always make sure the left is the smaller and the right is the larger. And that's your answer. And then you still want to check this in a calculator. So I've already plugged it in. So we hit zoom 6, and it should give us that same graph going through, there it is, see? And you test your zeros. So trace negative 2, we're good. Trace negative 4, we're good. And so you can see this line is 0. If I were to graph 0 in there, it draws the line. So this is where our function is equal to 0. These are our zeros. And so this is when it's less than 0, and this is when it's greater than 0. So it's between negative 2, negative 4, and negative 2. You can also use Desmos. So I've plugged it into Desmos, and from here you can see the red is the less than and the right is the greater than. So if we had changed that to a greater than, so this had been greater than or equal to 0, then our interval would be from negative infinity to negative 4, bracket because it's equal, and then from negative 2 to infinity as well. So that would be our answer. And now if I had made this just plain old greater than 0, then it would be from negative infinity to negative 4 parenthesis and to infinity parenthesis. So it's just the regions that are greater than and less than. That's all we're looking for. So let's try another one. So on this one, we're going to set it equal to 0. We always want to set it equal to 0. So you're going to add that 6x over to the other side. And then that way we can look at just that x-axis again. We're going to get that same basic graph. So on this one, we have a common factor of x. And again, we're looking for the zeros. And then we factor that inside one. That's 2 and 3. And we end up with x equals 0, x equals negative 2, and x equals negative 3. So if we put those in order, negative 3, and it doesn't even matter about spacing, just put them on there. You can space them all evenly. We're just using this as a picture. Now we're going to connect the dots, and we can do this logically. We already know it's an x cubed, so our end behavior is this, and everything else is 1, and so it's just going to connect nice like this. And then we go back and look. This one also wants to know when is it less than 0. So this part is below the line, which would make it less than. And this part is below the line, which would make it also less than. So our answer would go from negative infinity to negative 3, bracket, again because it's equal. But this region is greater than, so we don't want to include it. Then we put a union, and then bracket negative 2 to 0, parenthesis. Oops. Bracket, because it's equal. And then from 0 on, it goes off to infinity. And again, we'll check this in our calculator and Desmos. So zoom 6. We wait, and there we go. So there's our 3 answers. There's a negative 3, negative 2, and 0. It's drawing the line for 0. So you can see there's a graph, negative 3, negative 2, and 0. It checks out perfect. So it is less in this region and in here, and then greater from there. So you can see this is the region. So from negative infinity to negative 3, it is going to be less than. And then from negative 3 to 2, it's greater than, so we don't include it. And then from negative 2 to 0, it's also less than. And then from 0 on, it goes straight up. And we know it's going to go on forever because we have a cube. There's at most 3 zeros. It's not coming back down. If it did, it would cross again. So these are the 2 regions that we get. And you can see in Desmos, we have the same thing. See, so from negative infinity to negative 3, it is less than. From negative 2 to 0, it is less than. These are the greater thans. So if that had been a greater than or equal to, like that, then our answer would have been negative 3 to negative 2, union 0 to infinity. So let's try this one. So now we got to move everything over, and we can move it over here and get a negative x cubed, but I want to keep everything positive. So I'm going to move these over to the other side. So we'll put the negative x squared right there, minus 7x plus 3, cancel, cancel, cancel. And I get 0 is greater than x cubed minus x squared minus 6x plus 3. Now I like everything on the left side, so I'm just going to do a little Photoshop here and switch them. And so that would now be less than 0. See how the arrow is pointing to our polynomial? Just got to make sure the arrow stays pointing to the polynomial. So minus x squared minus 7x plus 3. Mistake. That's why we always check. There we go. So that would be x cubed minus x squared minus 6x plus 7. And on this one, it says find the real approximate zeros. So what that means is this is not going to be nice. And so we're going to need to use our graphing calculator to find our zeros. So we'll take and hit zoom 6 to graph it. And since I have the y equals 0 line, I don't have to use the 0 function. I can just do second calc and then find the point of intersection. So between the blue and the red, it intersects at that one. So 1.22 is one of them. And then we keep doing that. So first curve, now guess, and then you scroll next to the one you want. So 2.29, so 1.22, 2.29. Should write these down, huh? So let's draw a picture. So we know 1.22, let's say I already forgot it. 2.29, all right, that's what I was thinking. Okay, so these are approximate. That's what it's asking for, not exact, approximate. So sometimes we don't have exact values that are easy to find. So you have to use the approximate ones. So we go back to our calculator. We got one more left to do. So second calc intersect. First curve, second curve, and then we need to be near here. So you can scroll over or you could just enter the number. So I'm just going to enter in -2. And then that way I'll be close to it. And there it is. So -2.51. So -2.51. And then we already know what our graph looks like from the picture. It has that same cube and behavior that we knew we would have. So we already knew that it's going to do, I should move this guy a little bit, negative 2.51 up here so that it comes through nicely. So we know our graph is going to have this in behavior. It's supposed to be in green, like that. And so it goes up, goes down, and then goes up. And so right now you can see that our function is also less than 0. The way I've written all of them, they're less. Now if we had gone the other way, it would have been greater than 0, and our graph would have been upside down. But it's not. So we're again looking for less. So we want this area here, shade everything that's below the graph from the line to the graph. And then this area as well. These are all values that are less. And so our answer would be, this is only a parenthesis this time, so negative infinity to negative 2.51, parenthesis, union, parenthesis, 1.22, 2.29. So that's our answer with approximate 0. So if you can find exact zeros, go for it. But if you can't, you can use the approximate and get an approximate answer. So let's also check this in Desmos. So here we go again. There's our graph, 0.1, 0.2, 0.3. So those numbers match exactly what we had in our graphing calculator. And so it's less than here, greater than here, less than, and greater than. So you can see all the different answers here. So if we had this as greater than 0, it'd be from negative 2.5 to 1.2 with parentheses. And then if it was greater than or equal to, it'd be from here to here and from here to infinity and so on. So if it's above, it's greater than. If it's below, it's less.